Welcome to the 6th Annual Innovations 101 Mechanical and Industrial Engineer Department Showcase. I am Carly Miller, a freshman ME student, and I will be one of the MCs of this showcase. This year's MIE FED 101 Showcase is honored to host projects from the 101 Honor Section, the Learning Communities, and the Non-Learning Community sections. Before I proceed any further, I request that the chairman of the Mechanical and Industrial Engineering Department, Dr. Joga Rao, to present the welcome address.
Thank you, Carly. So welcome everyone to the Innovation 101, the Mechanical Engineering Fundamentals of Engineering Design Showcase. So before I get started, I just want to give you a little background for the event. The event started in 2011 and had 90 students in the first engineering showcase. And since then, it has grown every year. And this year, we have around 150 students. And this is the 6th time we've had this event. And each time, it's been a success. It's become bigger. The projects have become more complicated and more interesting. So I think there's just been a lot of growth and really a lot of improvement every year from year to year in the event, just from seeing it, observing it over the years. And the aim of the event is to introduce students to engineering design and innovation utilizing reverse engineering. And as we know, reverse engineering has a long history in both science and engineering to both understand how things work, but also to learn from prior inventions and to come up with something new, more better and more innovative. And I'm sure most of us engineers, when we were young, we used to like tearing things apart, and sometimes maybe our parents weren't that thrilled about it, but we did it anyway. I know that was definitely the case for me. So here, the students in this Innovation 101 get to take it to a whole nother level. They're broken up into students of groups of approximately 3 students, and they typically pick a device. And this year, as you walk around, you can see the devices range from biomedical devices to water sprinklers, to drones, to alarm clocks, to parts of a bike. So just a whole range of devices. And then they go on to dismantle it, draw CAD, use the software Creo to see how all the parts fit together. And also research the patterns to see where these ideas first originated or where they came from. And also today we have senior engineers from local industries to serve as judges. We have family members here coming here to cheer on their students, their kids. And we also have alumni of Innovation 101 who have also dropped by to reconnect with the program and just to share what a lasting impact it's had on them. So one of the things that this program really does is it truly creates a learning community where you have participants from all over, like alumni from industry, from faculty, students, and even their family. And as we can see from looking at the different projects, this year the enthusiasm and the complexity of projects, it's obvious that it's, again, a huge success. And the one thing I always want to keep in mind is that these projects have been done by students who have been on campus only for 3 months. So it's not done by someone who's been here for a long time. These are like students who have been at NJIT for a short period of time, and it's really commendable, the amount of effort and the detail they put into it. And also just a little bit about our curriculum, like they're doing the reverse engineering in this very first semester, and in the last year they're actually going to design something from scratch as part of their capstone design project. And both together really form a great bookend to their engineering career, where they learn all the techniques and the engineering skills in between the beginning and the end. And also, another thing I just want to point out is that Mani was just telling me earlier that a lot of the students who do really well in this Innovation 101, many of them have gone on to work for really big companies like Lockheed Martin. Many of them have gone to grad school at schools like Stanford and Georgia Tech. So the ones who do well really learn a lot from this course, and they take it to whatever they do pursue later on in life. And we're going to see some of the alumni speaking today later about it. And so lastly, I just want to say that we in mechanical engineering and industrial engineering are extremely proud of the showcase and all that it accomplishes. And I think it goes without saying that the reason why the showcase is as successful as it is because of Professor Mani. And Professor Mani, like when the first showcase, the idea was brought up, he did a pilot project in 2010. That time, people thought that maybe it wasn't going to succeed, but he's really put his heart and soul into it, and because of that, it is what it is today. And I really want to acknowledge him. Mani, do you want to please stand up? Thank you, Professor Mani, because your dedication to this really shows when you see how well it goes and how amazing work the students do. And I also want to thank Dr. Moon, who was the instructor for the FED for the first time this year, and he did a really good job. So thank you, Dr. Moon, wherever you are. Lastly, I want to give a big thank you to all the judges, the mentors, the volunteers, the family members, and of course the students for being here and making the showcase a success. And for the students, I really hope you take the passion and the purpose that was sparked in this course and keep that flame alive, because as you look at the world around you, there are a lot of really big and challenging problems that we need you to go and solve once you become full-fledged engineers and leave NJIT. So thank you very much for being here, and I really look forward to the rest of the program.
Thank you, Dr. Rao. My name is Corbin Dix. I am a freshman mechanical engineering student here at NJIT, and I'm going to be your other MC for the remainder of the showcase. Now, for this project, we were asked to pick an item or tool that had some sort of mechanical functions that we could take apart and reverse engineer. Now, we were tasked to understand the way that the tool works and functions and put it back together in a CAD program. The showcase started, like Dr. Rao said, with the support of the learning communities when they first started at NJIT. It started with 90 students, 30 teams, and had 15 different projects, and now has over 47 teams and 145 students showcasing their work. It has been a grand success ever since. I would now like to introduce the Dean of said students and the Dean of Learning Communities, Dr. Laura Valente, to share her thoughts with us.
Good afternoon, everyone. I hope everyone is doing all right on this lovely day. I am Laura Valente. I am your Dean of Students and Associate Vice President for Student Engagement. And I am honored to be able to talk with all of you for a few minutes this morning. Much of what you really kind of need to know about the showcase has been explained to you already. But the reason that I'm here is because of one of the last things that you just heard, and that is the connection between the learning communities and the FED 101 showcase. The learning communities is a program that has a very unique sort of mission. The Learning Communities program is designed to sort of reduce the psychological size of the university. Freshmen come in and they are one of 1,200 students setting foot here on the first day of school. And that can be a little overwhelming, especially for those freshmen who came from relatively small high schools. So you come out of a senior class of 250 people, and all of a sudden you're one of 1,200. And what we find is that students who are in sort of specialized programs, whether it's in the Honors College or EOP or perhaps even their athletes or something like that, they have this ready-made smaller community. And what we're trying to do is to make sure that every student who comes to NJIT is part of a more intimate academic community, and the Learning Communities tries to do that. So by putting folks together in cohorts, And in NJIT's case, we group most by majors. We assign peer mentors. We link courses so that most students see their colleagues in more than one class that first semester. It's easier for bonds to be formed, et cetera. And we think that that's what we can do to help students be more academically successful, because data across the nation shows that students who are part of an academic community, who feel included from day one, who feel that they are part of a group, that they have peers, that they have equals, that they belong someplace, they are more likely to have a higher GPA, to have more credits earned, okay, and they're more likely to persist into the following year. And what our data shows is that being in the learning communities does that for NJIT students, where we see that, as do universities across the nation, all of whom have different learning communities. The models differ depending on the sort of place that students are going to school. In our case, it's a STEM university, and so making something like an FED 101, and specifically the showcase, part of learning communities is an especially successful collaboration. And the learning communities, yes, are run out of the Dean of Students office, but it is tightly woven with the academic side of the house. It is the premier example on this campus of a joint program between an inside and an outside of the classroom experience. And so we in Student Affairs make sure that we are working with the academic side of the house to engage students in such a way that they are engaged with each other, with the coursework, with the content, in a career sort of context, but with a hands-on approach. And the FED 101 showcase is an amazing example of how all of those things can come together in one program, in one activity. And so our hope is that by having a course such as FED 101 and having peer mentors and having linked classes and having access to the Learning Communities Lounge and having an assignment like this where you're partnered with your peers and you actually do something, right? You do take something apart and you figure it out and you redo it and you improve it and you're creative. All right, because anybody who's outside of a STEM university might not think that engineers are creative. They think of artists as creative, or maybe actors or singers or something. Obviously, engineers are creative too. We wouldn't be where we are today with everything from an iPhone to a drone if engineers were not creative. Because engineers think of the things that we didn't even know we needed, and then they fulfill a need we didn't know we had. Okay? And so I, as the Dean of Students, probably the least engineer-like person you could have. I am in constant admiration of what you guys can accomplish. And I'm impressed by what you do, and I am thrilled at the collaboration between my office and the academic side of the house and the College of Engineering can result in such an event for you guys. And I hope that it was as meaningful for you to participate in as it is for us to try to put it together. So I wish all of you luck today, and I also want to thank the faculty, the judges, the mentors, everyone who had a hand in putting this together. Thank you very, very much.
Thank you very much, Dr. Valenti. An essential part of this project is to design and plan for what you are going to do. To do this, we followed a PERT, which stands for Program Evaluation and Research Techniques. We also created a DTP, which is a design task plan to break down the amount of work we had to do in order to accomplish it. These two things were very important to being able to finish our projects on time. Now, our next speaker is a graduate from NJIT. He worked for IBM as an executive for 34 years. He is a part of the NJIT Alumni Association and is now back as an adjunct professor in the School of Management. I would like to introduce Mr. Jack Wagner.
Well, good afternoon, everyone. You know, I was reading through the brochure, and one thing in here you want to take away with you. You know, every year the names change, the program changes, but the one thing you want to remember is whatever you do, do it with passion. Now, I know that's Professor Manny's mantra, but it's more than just a slogan. It's more than just doing this program. It's more than just doing what's in this class. It's about everything you do. If you don't have passion for something, I guess the question is, why would you do it, right? So again, just focus on that. Now, thank you for that introduction. Yes, I am a graduate of NJIT. In fact, I was computer science and industrial engineering. There was no school of management back then. That was back in, when the cavemen ruled the earth, I think. But also, Professor Rao mentioned something earlier. We're all engineers. We like to take things apart. Well, I grew up like that, and it was easier to take things apart back then. I took my parents' TV apart once. They weren't real happy about it, but it was not taking like these TVs apart. You could take the picture tube out, you could take the vacuum tubes out, and you could try to figure out how it worked. I never got that far, nor did I ever get it back together. But taking things apart is fun, as you've demonstrated here. Taking things apart is fun, but you're doing it from a learning perspective, and that takes it to the next level of fun. That takes it to a level of passion. It's amazing to see the work you've done. And as president of the Alumni Association, I've been proud to be involved with this program for the last few years. And it really is truly amazing to see the work you do. Interesting, my other job is working in the School of Management these days. I also manage the freshman classes, so I manage the freshman cohort. And we have our equivalent to this. And I break my class up into teams like yours, but they don't take something physical apart. They take a company apart. And they each pick a company, and it might be because, they like the company's products, or they've dealt with the company, or it's, they all want a Tesla, so they pick Tesla. But their view of these companies is as a consumer. So now I want them to take a view of these companies as a business person. I want them to dissect the company, just like you've dissected your products here. A little bit different, but the same methodology. And that's the value in being in NJIT. And in the School of Management, we call it business with the power of STEM. We approach business from a technology perspective in the School of Management, just like you approach technology here. But guess what? You also have to have a business perspective as you go out into the business world. You've looked at these companies' products. Now the other issue is, how do they get them to market? How do they run the companies? What's all the other pieces that have to fit together to take that product and make it pervasive in the world and make it successful? And that's all the pieces that can come together here at NJIT. So you've taken that first step down that road as freshmen. As an alum, I am extremely proud of the work you do. By the way, I mention it all the time when I'm running around the country talking about NJIT, and when I am hosting open houses for potentially incoming freshmen. And I explain this process to incoming students or their parents, and they are all amazed you get that hands-on experience. And then I think back to my days as a student. NJIT has always been a hands-on university. And that sort of methodology that NJIT is a hands-on college has always been around. And I think it's what sets us apart, because it's not theory. It's not something you do in the classroom and then go home. You know, I was talking to students today who were working on the gears of the bicycle, and they were saying they couldn't get it apart, so, you know, they took it home and worked on it with a hammer. You know, and they still couldn't get it apart, so they took it to the local bike shop and asked if they could go in and use the bike shop equipment to try to take it apart. That's passion. I mean, that is passion. It's not like, okay, 3 o'clock's here, school's over, I'm going to go home and do something else. So that's the kind of passion you want to bring to everything. And there's one other element that you need to remember to bring that passion to, and that's your career as you go forward. Yes, you're a freshman. Is it too early to think about your career? Absolutely not. Approach it with that same passion. You have to understand yourself, document yourself, and I don't mean just writing a resume, but now it's participating in things like LinkedIn and all the other tools that are available. And then market yourself. And by the way, when you market yourself, it's always good to have a demonstration. And guess what you've got right here? Phenomenal demonstrations that you can carry out into the business world and say, look what I've done. I can show it to you. And that's what works. So great job, great program, something that the Alumni Association always wants to be involved with. It's a little late to welcome you to NJIT, but I welcome you to the end of your first semester, and it's coming up quick, as you well know. Thanks a lot for having me here, and have a great day.
Wait, so how do I? There we go. Where we at? All right, cool. All right, so thank you, Mr. Wagner. Another thing about this project is that when it comes to innovation, you know, one needs to know the developments that went into their items and, you know, whatever it is they're working on. So what we did is we researched patents, current and historical, so you can see, so basically we can understand how the products that we were working on evolved. And understanding the history of the tool that you're, you know, reverse engineering is something very important in this innovation project. So now I'd like to introduce the Associate Dean of Academic Affairs, Dr. Edwin Howe.
Good afternoon, everyone. I'm delighted to be here joining all of you for the 6th Annual Department of Mechanical and Industrial Engineering Freshman Innovation 101 Showcase. I want to thank Professor Roll and Professor Manny for organizing such a wonderful event for the MIE students. I had a chance to speak with some of the students, and I'm very much impressed by their projects and presentations. I understand that this year we have over 140 students working in 47 teams and on nearly 30 different projects. This annual event has grown significantly since its first inception back in 2011. So far, more than 600 MIE students, first-year students, have benefited from this program. And MIE department is the largest department within the college, and I expect that to continue to grow and continue success with this program. The Fundamental of Engineering Design FED 101 is a course for first-year students in all of our engineering programs. One of its goals is to have our first-year students learn about the engineering process through hands-on experience so as to inspire them to continue studying engineering. The MIE department has adopted an innovative process of using reverse engineering as a learning tool. Reverse engineering is a technique in which students learn how a particular piece of equipment works by breaking down into fundamental parts. The analysis will allow the student to understand the purpose of each individual element contained within the system. He or she would then be able to construct their own device which performs the same function and includes all the necessary components. MIE department has integrated the reverse engineering concept and 3D computer-aided design modeling tools and provide a very meaningful hands-on engineering experience for their students. Not so long ago, students who want to study engineers are thinkers when they were growing up. You could be playing around with electronics, like taking apart a radio, or cleaning and rebuilding a carburetor of an engine. Nowadays, with the tools that are available, you could have experience in building gadgets with 3D printers and Arduinos. And I would like to mention that NCE is in the process of creating a makerspace on campus, which will provide you with advanced tools so that you can create, invent, and learn. Although the experience that you experience will be different, the main ingredients remains the same. And this is basically the theme that all the previous speaker has been talking about. And that is the passion for the work you do. Our job here is to provide you with the knowledge and tools so that you can pursue your passion. Once again, I want to congratulate the student here for a job well done and wish you continued success in your study at NJIT. Thank you.
Hi, my name is Ashley Pettish, and I'm a second-year mechanical engineering student. As some of you may already know, last year in my innovation showcase, I worked on the laparoscopic device. Despite some of the many roadblocks I encountered along the way, when preparing for the showcase, I was selected to represent NJIT in the undergraduate division at Johnson & Johnson's Engineering Showcase. Last year at the Johnson & Johnson Engineering Showcase, I had the pleasure of meeting our next guest. He has a background in chemical engineering and over the past 30 years has worked in the pharmaceutical industry. He began his career at SmithKline Beekman, where he was involved in manufacturing operations in Puerto Rico and the Bahamas, and later engineering and maintenance in Philadelphia. Then he worked with Lonza as a general manager. Following Lonza, he owned his own engineering consulting firm. Then he became part of Johnson & Johnson's team, having part in manufacturing, process technology, engineering, facilities, maintenance, project management, design to value, and project portfolio management. Currently, he is a strategic operations lead at Janssen. Please welcome our next guest, Brian Cherry.
Good afternoon, everybody. Dr. O, I don't know if Professor Manny let you know that he invited a chemical engineer into your den of industrial and mechanical engineers. But what I thought I'd do is give a perspective as an engineering as a profession, and things to look forward to, and perspectives from somebody that's been in this profession for 30 years. And the theme of it is a journey of continuous learning and application. So as other speakers have pointed out, you're at the beginning of your journey of learning, but it certainly doesn't stop at graduation. I've been graduated over 30 years ago, and I'm still learning. And the beauty of life as an engineer is you never stop learning, and you're constantly reinventing yourself, and you're constantly learning. My father-in-law, who's turning 80 next year, is a retired electrical engineer. He worked for many years back in the days, transitioning from the vacuum tubes to the transistors and then through robotics. And he's kind of shifted his in post-retirement, he's involved in alternative medicine, and he's kind of embraced this new technology and is constantly researching, much to my chagrin, as he comes and challenges me from the pharmaceutical industry why we're not doing things differently. But the key message is one of continuous learning. And then the trigger and the key things we bring as engineers is not just the learning, but then the application. Because when we learn and we apply, and we look and adapting what we learn, and we apply it to the betterment of society, for patients in my case, for the environment, for customers, for society, that's where we bring, and that's what the profession of engineering does. So it's a very exciting profession, And I think if you keep that in mind, that's something that will last you. Inspiration, Mr. Wagner earlier talked about a passion, and I see the passion in the room. But what inspired us to come here? What inspired you to choose engineering as a profession? And when you look at what inspires you, that's something that carries you through your career. So if you look at what inspires, and if I can share a little bit about what inspires me.
Hello, and welcome to our first program of this series of Junior Physics. A special welcome to those of you who have been through the mill last year and have come back for more. Now, the title of today's program is What is Physics? It's a question I put there myself, and therefore I'm faced with the answer. How am I going to answer it? How can anybody answer it? The subject is so big, it has so many ramifications that it's really a superhuman thing. It requires a superhuman effort, if you wish, to answer it. But let's try and give at least an indication of what physics is about. It's a subject that examines and measures a variety of properties of matter. It does more, of course, but just for the moment, let's stop there. It examines and measures a variety of properties of matter. Now, by property of matter there, we don't mean something that we own, for example, a watch or a car or a house. We mean a characteristic of matter, like smell, taste, or heaviness, or solubility, something of that order. Whether it can conduct an electric current or whether it can't. Now, it examines a lot of these properties of matter. It also has a close look at many forces, at lots of various types of motions. It deals with sound, light, electricity, magnetism, and so forth. So it really is a big subject.
So I found that in the archives of Televis Scola, which was the Irish television station. That's 50 years old, and if you don't recognize the resemblance, that's my father. And the story around this was in the very early days of Irish television, they were very innovative. They actually used the very early days of Irish television as educational programs. And of course, then we rented all the shows from America, I Love Lucy, and all the rest of them. But during the day, they used television as an educational tool. My dad was a teacher, taught me chemistry for 5 years in school, but he was one of the first presenters. This I found in an archives by searching it when I was trying to explain this to my daughter. This was from 1964. You can see the black and white TV. But I remember this brought back a very poignant memory for me. I was 6 years old. I was in elementary school. And my dad brought me home from school early so he could watch, like he could share and have me watch his first broadcast. And I remember sitting in the living room, and my dad was there, and I was there, my mom was there, and the television program came on, he came on, and then I looked at my dad in the room, and I looked at my dad on the TV, and I looked at my dad in the room, and I said, how can you be inside the TV and in the room at the same time? So that's funny to you guys because you're surrounded by this technology, but those of us that are a little bit older can remember, what technology meant. And in that, for those young eyes, technology was how could you fit in a box and present a box. So, my dad has passed away from Alzheimer's. So my career in the pharmaceutical industry and applying engineering in pharmaceuticals to try and influence and help patients is my inspiration. So my message to you, find your inspiration. That's my inspiration, but everybody has their own story and everybody has their inspiration of why they're practicing engineering, why they're doing what they're doing, because that's what really grounds you as you go through your engineering career and your life career. And many of you recognize what this is. Come on, I won't look at the front row here, or in the back row. Who knows what this is? Slider. Who's actually used one? Wow, I'm impressed. I know the old guys in front know. I know you guys have used one, but I'm impressed with some of the hands in the back. So when I went to college, this is what I used. Calculators were just coming out, but they were still a bit expensive, so we still had to use slide rules. By the time we get to graduate school, we used calculators. But I'm just kind of showing that, we're talking about all this amazing technology, and if you look just through my career, this is some of the innovations and the technologies and the advancements in technology that have happened since I graduated. So yes, the PC was invented after I graduated. Strange that you guys can think about that. But when you look at some of the amazing technology and how that has shaped my career, how that has shaped the engineering profession, how we've used that and applied that, and for example, in pharmaceutical industry, in the medical industry, 25 years ago when the AIDS epidemic first came out and people got HIV and then AIDS, that was a death sentence, no question. But we innovated and came up with protease innovation technology that spawned new pharmaceutical products, and then it evolved, and now it's a manageable disease. And people can have life, and it's complicated, it's intrusive, but it is manageable, and people can live long and relatively healthy lives. We're embarking in my company, Johnson & Johnson, on a stem cell product, and the technology and the manufacturing process is totally different than what we've been doing in the past. So the key about engineering is what you learn now and the technologies we learn and the technologies we apply. That's the foundation. When you come up here in 10 years' time, when you come up here in 20 years' time, your list is going to be totally different. We can't even imagine what you'll be sharing to the people you address, the students of the day, of the technologies. Who could have imagined when I came over here to the United States as a graduate student, it was too expensive to telephone home all the time because there was no cell phones. I see some nodding heads here. So it was a totally different world. Who would have contemplated something like an iPhone? It just was not in the realm of thinking. So the types of things and the type of technologies and innovations that you'll experience and you'll be part of creating is what makes this such an exciting profession. And you as engineers, this is the foundation, but continuously through your career, all the way, it'll be a combination of learning and application. And the way we're looking at it a little bit now, and you may have heard from this, is we're really entering a fourth industrial revolution. So we all know the first revolution with the advent of the steam engine and the looms, the second with the assembly lines, and the third, which is when I graduated, when we had programmable controllers, automation, and we thought we were really advancing. But now we're into a fourth industrial revolution, and that's really about the whole cyber physical connectivity. And this is the definition that we pulled out. What is the fourth industrial revolution? It's the area of digitization and the cyber physical interconnectivity. So that's really the confluence of digital, physical, and looking at that as an integral ecosystem. And that provides great opportunity, again, to apply that to help customers, patients, fill unmet needs, address societal issues, but it's a whole new revolution in how we're thinking. And in our world, in my manufacturing world, we look at the connectivity between smart services, smart factory, and smart products, all connected through the cloud and through this digital connectivity. So we're thinking a lot differently around technology and how to apply it. And if I give you a little bit of an insight as to how we're thinking about this new world in Johnson & Johnson, we start with our foundational enablers of technology systems, our J&J production system, core environmental health and safety values, and our quality. And these are foundational. But then we're looking to build upon that, this whole concept of how do we leverage digitization, 3D printing, smart sensing, big data analytics, and then leverage new technologies, disruptive technologies. How we then leverage the resources, we need to pull that together, whether it's natural resources and how we do that in a sustainable way, or it's human resources. And then how do we then look at that and how we influence the customer, the patient or the customer, how we give better outcomes, how we give personalized outcomes to the customer, how we look at the connectivity between the influences of the society around us, policymakers, legal or regulatory, commercial, how we connect with partnerships. How do we do this through partnerships with academia, partnerships with other companies? And ultimately, how do we use this to transform our organization? So this is how we're looking, just one view as a company, how we're looking to harness technology and what we're looking at as the fourth industrial revolution, and how we're looking at that to transform our company. And we're looking at then some applications of that in 3D printing in the medical field, in advanced robotics for lens manufacture, et cetera, et cetera. So the key message here is not just to share what we're doing, but is to show that as an example of what you'll be doing in your career. And adapting technology, continually learning technology. Most of what I do now with whether it's biologics manufacturing, stem cell manufacturing, advanced, these are things that I did not learn in college. What you learn in college is the foundations, the fundamentals, the discipline, the analytical capabilities, and the passion for learning, and applying that learning, and then applying that to solutions. So that's kind of the key message. But the final thought I'll leave with you is to make that a reality, it's all about leadership. And when I mean leadership, I don't mean whether you're the president of the company or the vice president of the company, but I mean how you lead and how you drive change. And you're going to see lots of different books about leadership and lots of different concepts about leadership. But if you want to pick one, I would recommend Bill George's True North, Discover Your Authentic Leadership. And he's got a number of very fundamental principles that's helped me in my career, and I would propose that it would help you as well. It's Professor Manny, pursuing purpose with a passion. Use your inspiration, pursue your purpose, drive it. People will gravitate to you if you have a passion about what you do. Practice solid values. They're not my values, they're your values. Yes, companies have some core values, society has core values, but ultimately understand what your values are and become a value-driven leader. Leading with a heart. Wait a minute, we're a bunch of engineers. We don't have any hearts. We're about data, we're about analytics, we're about facts. But ultimately, when you pull that together, you're influencing people. And people gravitate to how you apply that and how you bring that extra personal energy to what you do. Again, you can't do things on an island, so you need to have relationships to succeed, whether it's partnerships, collaborations, deep relationships, connections. That's all part of how you succeed through leadership. And finally, the self-discipline and the ability to be self-analytic and understand yourself, learn about yourself, learn from your mistakes, and continuously grow as a leader. So I think that's really the lasting message I would want to give is when you look at engineering as a profession, to me, there's no greater foundation for a really valuable and very worthwhile and fulfilling profession if you stay inspired, continue learning and applying it, and build your ability to lead and apply those solutions to the betterment of society. So thank you.
Okay. So thank you very much, Mr. Sherry. What was that? So now we're going to have a former student come and address us, but before she does, I'm going to tell you a little bit about her. So she was a mechanical engineering student and graduated with a bachelor's degree in 2014 and her master's in 2015, and they were both from NJIT. Now, while she was here, she was the vice president of PACE, which is the Planning to Achieve Collegiate Excellence group, and she was also initiated into Tau Beta Pi, which is the Engineering Honor Society. She was also an honors ambassador and an employee of the Murray Center for Women in Technology. She's currently working for Valcor Engineering Corporation, into which she has been held many different roles. I would now like to introduce Ms. Laura Spinelli.
Good afternoon. My name is Lara Spinelli, and I'm a proud mechanical engineering graduate of NJIT. Let me first just say how phenomenal of a job you all did here today. I'm truly impressed by all the hard work you guys put in. It's really unbelievable. Where do you see yourself in 5 years? That's the question that seems to be constantly asked of us. Luckily, you're all students at NJIT, where futuristic thinking is the norm. I can assure you, as a living and breathing example, that this school prepared me for the real world, not only with technology, but also with the interaction of so many unique people. When I was a student here, right from the start, I wanted to be a part of NJIT. I mean, a true, meaningful part of this school. It was the feeling I got right from the get-go. From freshman year forward, I got involved as an honors ambassador, held officer positions in 2 different organizations, worked in the Murray Center for Women, watched all the plays and went to 1 million SAC events, and got to know my professors outside of the classroom. Definitely do this if you haven't already. Some of them are truly incredible people with industry experience you wouldn't believe. My first piece of advice to you is to immerse yourself in everything NJIT has to offer, even the little things. Try something, anything, because you might like it. And don't be afraid to try and fail. You've all heard the saying, do what you love and you'll never work a day in your life. As a now full-time employee of an aerospace engineering company, I can't even begin to tell you how true that is. Valcor Engineering Corporation specializes in the design and manufacture of solenoid valves. In my company, I've worked as a project manager, assembly and test engineer, and design engineer. I will soon be rotating into a manufacturing role where I'll be responsible for continuous improvement with our hardware. NJIT equipped me with the tools I needed to be an ethical, honest employee. The projects I'm involved with include missile defense and many of the space programs for NASA. I have a daily obligation to make sure no product leaves the building that may have a technical issue. I know I'm not at the peak of my career, not even close actually, but I still have a sense of accomplishment and pride in the work I do daily. It doesn't feel so much like work, but more like meaningful daily challenges with outcomes that help the world in some way, even a small way. My second bit of advice to you is to do what you love, and you will work every day of your life, to make this world a better place. Now, think about all the engineered solutions that you encounter daily. Not only cell phones, ATMs, and calculators, but the lawnmowers, the washing machines, and the microwaves too. Someone, somewhere, at some time, had to conceive, design, and execute that project. Even though you may not yet see it, that someone is each and every one of you from the first day you wanted to be an engineering student. You are responsible from this point forward for that change, that improvement. So I have good news and bad news. Bad news first, you're all freshmen. You have that entire journey in front of you waiting to be mapped out. The good news, you're all freshmen. You have that entire journey in front of you that you can map out in any way you see fit. Start thinking where you see yourself in 5 years, and think about that at least once a year for the rest of your life. You will find that you can't perfectly plan out every step you take, but instead teach yourself to adapt to the growth and change that you will experience with every decision you make. After all, that's what an engineer does. We create growth and change to make this world a better place. Thank you.
Thank you, Ms. Spinelli, for your first-hand insight. The next part of our project included taking apart physical objects. Once we had them taken apart, we identify each part in our DTP and measure them to help aid in our modeling process. We have some students here who are going to provide some first-hand input in their projects. One of our first students is named Peter, and he went above and beyond. His project had 82 part models, which is the largest number of any part models in these past 6 years of this showcase. By doing this, he set a great example of his passion for his work. Another person who has been just as hard at work is a student named Paul Denning. In the case of Paul, he has showed no less passion than Peter in his pursuit for perfection in this project. I would like to now introduce some of our students, Paul and Peter, to show you their projects.
Just give me 1 second. All right, good afternoon, everyone. One thing that I realized today was that Professor Mani was right. Since day one, Professor Mani has always said that we would, when the day of the showcase comes, we will realize that all of our hard work paid off. I completely understand what he was saying of that now. As said, my name is Paul Denning, and I was part of Group 1, the pulsating water sprinkler. Throughout our project, we all of the members of the group encountered problems that we really had to pretty much teach ourselves how to do with the help of Professor Mani and other people. So basically how the pulsating water sprinkler works, that's it, is that as the hammer, which is pretty much the long piece, let me just go. As the hammer moves, it provides, as water is hooked up, there's a pressure that comes out of the nozzle, and then it flows through a channel that is hooked up to the hammer. So that provides a force that propels the hammer in the opposite direction of where the arm from the frame comes out. So then there's also a torsion spring that's hooked up to the frame and the hammer, which provides it another force. So that's how you kind of get that pulsating action. And then there's a whole mechanism pretty much here, which pretty much as it moves, there are these things called adjustment springs, and as this little lever hits an adjustment spring, that mechanism trips, and it just pretty much changes the direction and inhibits the hammer from moving as far, so that's what pretty much gives it that other direction of movement. So obviously this is just the exploded view of it. just some of the part models that I found to be really difficult was that this part, the hammer, so we need to use extrusions pretty much to extrusions like symmetrically about a plane. We had to make datum planes on the fly because there were many items that were like on an angle, so you had to make a plane that was angled to another plane. So then there was also, we also had to use the feature revolve to make cylinders. This part, the bearing sleeve, we also had to use revolve feature extrusions and something called a helical sweep, which is how we made the threads. Just one, extrusions, revolve, helical sweep, and pattern. Pattern just because we had to make multiple holes. This one was actually, even though it was one of the hardest, it was actually the most fun to make because it taught me the most. And it taught me in a way that it literally told me how like it was actually manufactured in real life. I had to make literally a sheet, then I had to make a separate model, which was called a punch form, and that literally punched the sheet metal, and then I had to cut it, extrude, make datum planes, and then in the very end I had to bend it, which is exactly how it's manufactured in the real life. And then just some of my drawings that we used, or that we made up. And then just some features that I saw that like were improvements pretty much since the original patent of it, was that the adjustment lever, which is just something that like tells how far the water stream goes. And then just the adjustment screw, which just diffuses the water. It doesn't really work too well. And then just some more improvements that I've seen in the real world upon this design is that it could have a wheeled base and also it could have stronger material used, which is brass, and the other parts could be made of aluminum instead of zinc. It had a step added to it, which obviously it's going to help drive it into the ground, and it has a free spinning hose attachment, so it's a lot easier to hook up hoses. And then the image all the way on the left is pretty much the oldest image I could find, but it still looks good, of like the original design. So it's a lot different than what is like currently available. One of the oldest historical patents we found was really, it was approved in 1969, but it was applied for in 1967. It makes an improvement on the original design, which is all the way on the left. It has a specific nozzle which doesn't allow any debris to get into it. And then another improvement that we saw in a more recent, but it's still like 30 years old, is that this one has actually a removable nozzle, which then allows different angles of the water projecting out of it to go. And then this is just the final assembly drawing of the whole product. But I found it pretty neat, like from beginning to end, to see it from literally having nothing to having a full completed model. That completely astonishes me that I even surprised myself that I could do this. But other than that, I really enjoyed this project, and I just wanted to thank Professor Monty. Whether it was 3 in the morning or 1 in the afternoon, he was always available to help me. So, thank you.
Hello, everyone. I'm Peter Janakakis. As you heard before, I made the Ryobi miter chop saw with my partner, Marcus. He was very helpful throughout the entire process, as was Manny. No matter what happened, no matter what issue, I always had those two to rely on. And all my friends who were in the class and other teachers in my family, they were all very supportive, and I was able to help my classmates if they had trouble with their projects. I learned many things from this project through design, planning, research, and no matter what it was always very interesting to see it go through. So pretty much, I got this project because my father broke it, and he's a contractor. He had the saw, and he damaged the product, and he couldn't use it anymore, or else it wouldn't give him the right results. So I took it and I brought it here to check out how it works. And pretty much, this is our exploded view. There is an electric motor that, when you click the trigger on the handle, it starts a reaction where the spindle turns the motor, or the motor turns the spindle, and the spindle turns the blade, cutting through the wood or material that you want to cut. I learned today that there is something called a runoff, and this runoff causes the blade to move away from the line that you want to cut. The one way that I think that we could improve this design, and Marcus and I discussed this briefly, is to place a spring on the opposite side of the blade so that when the runoff pushes the blade away from your cut, the spring on the opposite side would push it back towards your cut, preventing that issue. So we just have some more assembly renderings. We have 4 assemblies: the base, the grip, and the blade, and then the connections that put all the pieces together. Out of this project, we had 83 pieces. 121 of those were repeated and used over and over for a stronger connection. We have some drawings, as Paul had. More of them. This is a spindle. It has lots of grooves so that when it connects to the kinetic motor, it will spin, and the angle of those grooves will prevent more runoff and make a better design. This is the grip assembly. It shows all the parts in that list, and it shows the dimensions of the assembly itself. And this is a very crazy picture of all the pieces in the product. There are 83 circles there, and it's quite difficult to see the product itself. So I apologize for that. But these are Visio drawings. This is so that someone else who has not made the product can read your work in extreme detail and remake the model however they want with their changes. But it shows that you know your product, you can remake it at any time, and you're able to explain how to make it to someone else. And we have an animation that I'll show you later at the end of the presentation. So looking at different product manuals and operation manuals that I found online on Google Patents, I found this picture and many other manuals with descriptions of the products, how they worked, why they were made the way they were, as well as what improvements have been made over the years. So this patent was made in 2008, and it describes why the circular blade for Ryobi is patented and how it's different from other tools and why it's better. They have a grooved slot at the outside of the blade guard, and that allows for more sight into where you're cutting, as well as dust removal from the cutting location. We have more patents and then historical patents. I found that in 1813, Tabitha Babbitt created the first circular saw. There are some people who say that it was designed by another person. I'm not really sure. I wasn't back there. It's a long time ago. Lots of things might have happened. But over the years, there have been many designs, many improvements. And of those, there are tables that connect to the miter saw so that it's at standing height. There are different rotations so you can have different beveled cuts. There is now a laser sight on it so you can see where your blade is going to cut before you cut the line so you don't ruin your piece. There are also clamps so that your piece will stay in place while you're cutting it. My father didn't use that while he broke the blade. So. This is another picture from the patents that I found on Google Patents. And some improvements, as I was saying before. There was the stand, the adjustable neck. We were thinking about using a fan to suck the sawdust out from where the blade is cutting and into the sawdust bag that is provided with the machine. And there is now a motion detector, so if skin touches the blade, it will make a broken circuit, and that circuit will then trigger a safety mechanism which stops the blade by launching a pin in between the blade shafts and then pulling the blade down into the machine away from your hand. So it may break your machine and may cost money, but it's better than losing a finger. So these are just some pictures of our product as we worked on them. We have our base and our blade components. And on the right-hand side, we have our grip assembly, and on the left is our completed product. And now I will show you the video of our animation. Right. There we go. So I went to Nick for some help. He gave me great insight on how to use more Creo animations and how to figure out different problems in different scenarios. And for this problem, where the black miter or black retracting arm attaches to the head of the blade, I could not attach those two pieces, so I had to reference them and have them move at different speeds and different angles so that it looks like they're moving in one piece. So that's pretty much it. I would like to thank Professor Manny for all of his support, and congratulations to all of you for all of your hard work.
Okay, so thank you very much, Peter and Paul. It was very good stuff. So next, excuse me. After all our parts have been identified and measured, we basically build them in this CAD program that we've been learning in our classes. Professor Mani has been teaching us with a program called Creo Parametric. They're modeled and assembled to end up with a fully put together model of the tool that we're working on. So next, it's a great honor to have the Provost here to this function in the midst of his busy schedule. He's a great supporter and appreciates the values of what this showcase brings to the students. So next, I would like to welcome our Provost, Dr. Fadi Deek.
Thank you. Good evening. Thank you so much, Professor Manny, for inviting me to be here with you and your students and our visitors on this great campus. Congratulations, students, on having the opportunity to engage in this amazing experience, reverse engineering, or learning by doing, often referred to. The NJIT advantage, an advantage that you will encounter in your first year and your last year, and hopefully many different opportunities in between. In fact, it is an opportunity and an experience that is about to get even better, more enhanced, as we build for you, for us, for the next generation, for anyone who wants to use it, a major facility that we are calling the Makerspace. As you walk into GITC, going to your classes, if you have classes in GITC, take a look at the current old factory floor that is being cleaned to become a state-of-the-art facility where you can go in and show the creativity that you are showing in this course and have ample opportunity to turn your imagination on and produce things that you can only dream of. NJIT is proud to have you as a cohort of students in our great Department of Mechanical and Industrial Engineering, and thank you for your leadership, and thank you to our dean also, who's not in the room. Our associate dean is representing him, and thank you to every instructor and every mentor and every advisor. And certainly thank you, parents and other supporters, for being here for our students, for the next generation of America that is necessary for it to have the kinds of skills for them to thrive and do well in their lives and their careers. Congratulations again, and happy holidays.
Thank you, Dr. Deek. So now, as I know probably all of you are anxious, wanting to hear the results of the competition, so I would like to introduce Ms. Lucy Chwowski to come and announce the awards.
Good afternoon. I want to take this time and ask everyone to give all the students a hand for all the hard work. It is great to see everyone from freshman orientation to now, how focused, how dedicated they are, and all the hard work that they have put to get the project together. And of course, we want to thank all of them for all their hard work. Everyone is a winner because we know you all did great in FED. And it's something an experience that you will take with you for a lifetime. Just to be able to stand in front of someone, just to give a pitch, that you will take that with you when in your next interview. You will take that with you. Some of you will get opportunities from this experience. So remember, just keep working on that and learn from this experience and take it with you and build on it. This is part of your future. Right now, I will announce the top scorers for each of the sections. We have 5 sections. 3 of them are from the learning community: L60, L61, L62, and HO1, and section 27, which are the 3 learning communities are with Professor Manny, and the other 2 are with Dr. Moon Swapnil. So without further ado, I will ask you, once your name is called, I will ask you to stand up. We will start with the top scorer for L60, Team 2. We have Shannon Dugan. Nicholas Fertzek and Christopher Miranda. For number 2, we have a tie for the second place teams. We have Jason, Team 8, Jason LaBarbera, Adam Murphy, Zachary Ramos, Team 10, also second place scorer, Ali Murden, Christoph Rapp, and Christopher Ruffer. And for the third place, we have Team 6, Jason Kanak, Christian Phillip, and Matthew Stillman. Congratulations, L60. Now, L61, top score goes to Team 15, Zuhab Azam, Nicholas Critelli, and Jarek Hernandez. Second goes to Team 17, Mark Del Prado, Nicholas Skiffick, and Philip Thomas. For third, we have Anthony Amiran, Team 13, Anthony Amiran, Yusuf Nakla, and Andrew, Andrew, Some students do have class, so we do understand they have to run out for this part, but most of the students were present for the presentation and judging. Now, moving on to L62, we have top score, Samuel, Team 21, Samuel Altshuler, Bavid Upperday, and Tyler Wetzenberg. Number 2 goes to Team 29, AV, Jane, Joseph Major, and Joseph Mary Velarde. We have 2-team tie for number 3. Number 28, Janika Gray, Amy Peralta, Giselle Vidal. And number 30, Michael Kuzinski, Kaywan Mao, and Alexander Trio. Now moving to Dr. Swapnil sections, HO1 and section 27. For section 27, we have Christopher Constantino, team 33, Joshua Gellick, and Derek Kuttenperoro. For number 2, we have Eric Conti, team 37, Benjamin Nguyenhis, and Abraham Odman. For number 3, we have Alan Jones and Michael Wright from team 31. And section 27, we have for number 1, we have team 44, Zarak Jahan, Emmanuel Okoye, Toasif Sakar, and Elijah Uwe. For number 2, we have team 43, Matthew Zapp, Rebecca Modhello, Jamal Said. And we also have a tie for number 3, team 41 and team 48. We have Brittany Morales, Sean Pankerton, Natalia Riosco. And team 48, we have Fuad Bello, Carlos Abid, and Nick Santoro. Now for each of these sections, we have an overall winner for each of the Dr. Swapnil section and also Professor Mani sections. For Dr. Swapnil section, our overall winner, when I call you, can you please come up? We do have a small token of appreciation for your hard work. We have, for the overall winner, we have team number 44, Zarak Jahan, Emmanuel Okoye, Tuasif Sakar, and Elijah Uwe. Professor Manny, can you please come up? No, Dr. Swapnil, can you please come up, please? If you guys... Now for the learning community overall sections, we have team 2, Shannon Dugan, Nicholas Ferzak, Christopher Miranda. Professor Manny, can you please come up? Now, just a few, I guess, appreciation. We would like to start with Peter Ganekis. I'll probably butcher it, but I'm used to that. And Paul Dennings, if they can please come forward for their presentations. Last but not least, we also have a small presentation for all of you have been reading the brochure, going through the brochure. It takes a lot of work, and it takes a lot of editing and a lot of time spent between Professor Money and one of the students. And that she's also one of our mentors, Christina De Ramos. If you can please come forward. And last but not least, to get everything done every year is a learning period. We also take feedback from all of our students and so on. But we cannot get this done. I would like to really give a special thank you to some of the young ladies that I work with on this project this time. I would like Ashley Patesh and Shalene Longetti and Amaka to please come forward, just to so you can see them. They are behind the scene. They're here, work with me late, and they also work with Professor Manny, calling them and do all the stuff. Just so everybody can see them, all the hard work they have put in to get everything done. And we also have the mentors that part of the learning community. Some of them are not able to be here, but they came in to help as well. We have Ivan Calvaci, Eric McManara, Michael Philippidis, Christina De Ramos, Ashley Patesh, Shalene Longetti. So we thank you, all of you, for coming, and congratulations to all the groups, and hopefully that you'll continue to participate and help the learning community and showcase in the future. Thank you. The program is not completely over, so please don't leave yet. It was just the thank you part.
Thank you very much, Ms. Chuowski. So congratulations to everybody. The next and last person I'd like to introduce is somebody who's been there basically since my experience at NJIT started. You know, you've heard this a few times already. The one thing he always says is that if you're gonna do something, you do it with. Yeah, exactly, perfect. So Professor Mani has always been hard at work through sleepless nights, getting us ready for the showcase. And honestly, if it wasn't for him, most of us probably wouldn't be as prepared as we are today for this showcase. So thank you very much, Professor Mani. So I'd like to invite you up here for the vote of thanks. Thank you.
Thank you, Corbin. I didn't really prepare a speech because I was busy preparing you for the showcase, and you all did a wonderful job. Every one of you is a winner, right? So you should feel like that. And you know, by this course, you know what you did is you are able to see far beyond what your eyes can see and your minds can imagine. You know, you thought it is impossible to do this, right? You came and learned CAD modeling. The very first model we learned was a plate with a hole, right? You all struggled with that. And today you are showing the beautiful lamp I see there, and that skin stapler. You understand how these products work. I was so thrilled, when Peter Janakeks was explaining how that pattern, like a historical pattern of his, the Ryobi saw, and I saw, Paul Denning explaining about the sheet metal products. I never taught him any sheet metal. I just showed him some examples and told him I really don't have the time. And even made a complicated model which is not done even in our ME 430 class in junior class. So all this is because you're passionate about that, right? So what I was successful, what gratifies me is that I was able to trigger the inspiration in you, right? And that inspiration can propel you forward. Next 4 years, what is GPA, right? What is GPA? GPA is? Yeah, that is everything. That you have to make sure that I want to see number of 4.0s in this class, right? A number of students going forward to PhD, right? Higher studies, and become one of the stars 4, 5, 10 years from now. Then that will gratify me even more. I'm so happy to see all these things. My job is to propose the word of thanks. It's very hard because I have a long list of people to thank, right? Number one, I'm gratified, the provost could come here. He's a very busy person. He runs the entire school, the academic portion, and he is willing to be here, and because he loves what we do and how successful we are. My chairman, he is always in support for me. I don't have to run to his office. I can send an email. I get the approval right away. So that the type of support I have that made this kind of thing possible here. And another person I want to recognize is Lucy. She's a good friend of mine, and in the last 3-4 years, I've been working with her. She has become very, very close to me, and she takes care of a lot of things, and I cannot thank her enough as a team member. Talking about the team member, right? What made you successful is a team. You know what teams you were in. I had 30 teams, and Dr. Moon had a few teams. He has got about 20 teams. So what made you successful was the team members. In some of the teams were not very cooperative. They were not contributing, right? And that made it very difficult for you. So team is everything, right? That is very important, that you have to work with the team. You have a responsibility to contribute, and you have a responsibility to support, right? There is a book called Who Has Got Your Back? It was supposed to be one of the New York Times bestseller like 5-6 years ago, and I was introduced that book. It's a very, very good book. So every person is successful depends on who you are working with, who is your teammate. That is what makes you successful, right from your family, right? Your wife, or your children with the parents, and you with the students, you with your co-worker in an office. Wherever you are, right, you are successful as good as your team member, right? The team members can propel you to be successful, or they can also pull you down, right? But I saw all the teams working very well. This is your first semester here. This should be an inspiration for you. This should be an example that you want to take with you for the next 4 years and beyond, right? And be successful. And if I want to thank, next person is Dr. Swapnil Moon. He is newly joined in our department as a lecturer. He was a student here, but he took this very seriously, and he worked with me so closely, right? And we didn't meet face to face, but I was always aware of the progress that is going in his class, and he followed very meticulously. And I am very thankful to him to support this concept and bring his class students, very nicely, and they all showed wonderful projects. And I have another friend, Dr. Sodhi, who is here, who was working with me last 2 years as the complementary teacher in a couple of other sections. And he has moved on to some other program in the dean's office. And now Dr. Swapnil Moon is working with me. The mentors, Christina, Ashley, Shalene, and Michael Philippidis, all these students, I love them very much. I mean, they are very close to me. I mean, they treat me like a parent. They can talk to me anywhere, anytime. They can text me, call me, 12 o'clock in the night, whatever it is. We get the things accomplished. And we are successful because of their help. Mentors help the students. And another person, Nick Lonestrop, he is extremely good in CAD modeling. He has got some sort of a passion for that. And he came to my office so many times, right? And he wanted to help our students. I don't want to make my thank you very long, but I want to tell you that Nick was offered to be one of the technical resources for CAD tutoring, and that was possible because the learning communities person, Dr. Ashish Bankorkar, he was willing to give him that position. So see how the team is working. Here's a person who is capable of doing something, and he wants to do that. He wants to help other students, and here's somebody else in the learning communities. He comes around and he helps me. And all these things made, and Nick's name was mentioned by 2 or 3 teams here on the podium. So you understand the value of, this is the subliminal message that you should get. Hey, team is very important. Passion is very important. Whatever I take, I should do it perfectly. I should take it seriously and accomplish it. And that is what I want to do for the next several years to come. I have a long list. I have to thank Mr. Brian Sherry from Johnson & Johnson. I met him at the engineering showcase at Johnson & Johnson. I started liking him very much, talking to him over there, right? And I said, you are coming to my showcase, and I called him or sent an email to him. And in the next minute, I get an email, pencil me in, I'll be there. That's what he wrote. So I'm very thankful to Brian Sherry. And our Alumni Association, they were very kind to provide us all the gifts that we gave to all the judges. And they will be giving us more gifts for the students for the years to come, I hope, right? So thank you very much for your time. See, one of the things that I repeatedly tell in the class is the time. See, all these judges who came from industry, right? Larry O'Connell is the vice president at IBM, and he was able to find some time to come and support our event and by judging a few of the projects. See, all these people are dedicating their time. If you spend $5, I can give the $5 back to you. If you lost something, your house is burned, we can replace the house. But if you are giving the time away, I cannot return the time to you. Time is something that is not replaceable or not refundable. And these judges, in very responsible positions in companies, they are willing to dedicate their time for your advancement, right? And that's very important. That is where you should take the message, hey, all these people are supporting us, and I want to be number one. That's what I tell my children, right? Same thing I'm telling you because I treat you like my children. And you have to feel that I should be number one, and that should move you forward, okay? And I have another list of about 800 names. But I cannot thank everybody in a short time. But thank you for everything. Oh, another important, humanities department, right? I cannot leave them because they helped me so much. There's a small portion of writing which is the product description. It's not a big deal. I can read it and fix it. But I told my students, you have to go to the English professor, and then you have to seek their help and make sure your critical writing aspect is being addressed. And they cooperated, they helped me so much. They helped me so much, you cannot believe. And they bought into this idea, and we were working with the humanities department very closely. And I'm very thankful to Yuri Lee, my close friend, Mark Arnovich, and Dr. Phil King, right? They all helped me a lot. Thank you for them. And so I got a lot of help. It's because of the team we were able to be successful, and I want to keep moving with this process of doing the reverse engineering next year, next fall. And thank you to everything. Thank you for coming, Dr. Basil. Thank you for coming, and Dr. Koplik. He is here. So a lot of people are here. I'm very thankful to everyone, and it's hard, right? Thank you.
Thank you to Manny for all your hard work. We are very thankful for the many judges who are here with us today and everyone who took the time to speak to us. That brings us to the conclusion of today's events, and thank you all for all your participation.